Good evening, sir.
Yeah, good evening, Ishan. Sorry, I was muted. Let's see.
Yes, sir.
So, in the last class, we did about motion in a straight line, right?
Yes, sir.
So, let's try to do some more questions from motion in a straight line. And then
Okay.
after that, after those questions, we can move on to motion in a plane.
Sir, there are more problems, sir, in motion
Okay.
straight line.
What more problems?
Sir,
Like what?
yes, sir. Sir, wait, sir.
Okay, you can share it. And I think you shared also last week.
Sir, horizontal motion, sir.
What happened?
Sir, vertical motion, uh, horizontal motion, this type of problems, sir.
Yeah, vertical. Okay, can you just reshare the thing that you had shared? Because I think I need to find it out again through the message section.
Okay, sir.
Okay, so if you reshare it, it will be good for me. Okay, I got it, got it. You need not share, I got it.
Yes, sir.
So this is just one problem. Let me see this one. Okay, so now I can share the screen. You can have share.
Yes, sir.
Okay, so okay, there is something about instantaneous speed and average speed, right?
Yes, sir.
Okay. So let's talk of instantaneous speed, instantaneous velocity, also average velocity. Then we'll talk about the graph also. Did we
Okay.
discuss about the graph?
No, sir.
Okay. Okay, so let's continue. I think we just started over there. Okay, so let's see what do we mean by velocity, instantaneous velocity, and average velocity. So instantaneous velocity means the velocity of an object
At particular instant of
instant.
time.
Okay.
Yes, sir.
So
Yes, sir.
how can we find it out? Yes, how can we find it out?
Sir, at a particular instance, sir.
Yeah, at a particular instant, but the formula for velocity is displacement over time, right?
Yes, sir.
Okay, so if you are going to find out at a particular instant, so how you will find the displacement at a particular instant? At a particular instant of time, are you getting me? Something
Yes,
like
sir.
this. So how you will measure this?
Uh, Sir, is it
Okay, just
displacement by time, sir?
Okay, of course, the formula will be displacement by time. See, velocity is given by displacement per unit time, right?
Yes, sir.
So I want to measure it. Suppose I started at this point. Suppose at this point I started, and let's say I started at 9 a.m., right?
Yes, sir.
And I reached my destination at 9:20 a.m. So I want to find out my speed at 9:17 a.m. So how will I find it out? At 9:17 a.m. So how exactly at this point of time, how will I find the displacement at this point of time? That means I need see when I'm finding out the velocity, I am taking the displacement in a given interval of time. Like I'm observing the vehicle for a certain interval of time, okay, and then during that interval, what is the displacement? This is what I'm looking. During a given interval of time, I'm getting the displacement. So even if I written displacement by time, I need to write it as delta S by delta T. Delta T means an interval of time. So I will get the displacement only in an interval of time. So what interval of time should I choose to obtain the velocity at 9:17 a.m.?
Sir, at 9:17, sir.
Yeah,
9:17, sir.
yeah, 9:17. So
Okay.
should I take the displacement from my beginning point up to this point?
Yes, sir. A to B, sir.
No. If I take this complete duration, so during this duration, the object might have gone somewhere somewhere it might have attained high speed, somewhere it might have attained a low speed.
Yes, sir.
It may have happened that the speedometer of the vehicle at this point of time, the speedometer shows 60 kilometer per hour. At this point of time, the speedometer shows 120 kilometer per hour. At this point of time, the speedometer shows zero. So it can happen. So how will I get the exact velocity at this point of time? Okay. So to observe the exact velocity at this point of time, I need to observe the vehicle for a very small interval of time.
Yes, sir.
Okay. So
Yes.
maybe I need to observe from 9:17:00 to I may observe 9:17:01. So within 1 second, I want to see how much of the displacement it has made. Okay.
Yes, sir.
So since during that interval of time,
Yes, sir.
okay. So during that interval of time, the velocity doesn't change almost. Almost the velocity doesn't change during this interval of time.
No, sir.
Okay, so I
Yes.
can assume the velocity to be constant, and hence whatever displacement will be during this interval of time, I will divide that displacement by time, and the time would be just 0.1 seconds. Got it?
Okay, sir.
So
Yes, sir.
that I will get my instantaneous velocity. So for the instantaneous velocity, I must be taking the time to be very, very small.
Yes, sir.
So when I'm taking the complete time, for example, you said here, I'll be taking the complete displacement from A to B. I'll be taking the complete time from 9 to 9:17. Okay. So in that case, what the value that I will get will be the average velocity between A and B.
Yes, sir.
Okay. So to have the average velocity, if I find out the average velocity, it will be given by total displacement by total time.
Yes, sir. Sir, so here, what formula should I use, sir, in instantaneous velocity?
Okay. So for finding out the instantaneous velocity, I will be writing it as V equals to delta S by delta T. But the time delta T has to be very, very small. We call it infinitesimally small, almost zero. It's not zero, but we take this interval of time to be almost zero.
Okay, sir.
Okay. So
Yes, sir.
I'll be writing it like this somewhere. Limit delta t tending to 0. So limit delta t
Yeah.
tending to 0 means I have to evaluate this value when the value of the denominator or the time it almost becomes 0. It
Okay.
that means for this case I have taken 0 1 second. It may also be very big value. So
Yes, sir.
maybe I need to consider 0.001 second. Okay. So
Yes,
such
sir.
value will give me the exact instantaneous velocity. And this term in terms of calculus is written like ds by dt.
Oh,
Okay. So we
differentiation.
will be using calculus for finding out the instantaneous velocity.
Okay, sir.
So just another way, for example, suppose I have a ball being thrown vertically upward. So suppose here I have a ball and I throw it vertically upward. So here the ball is being thrown vertically upward to a certain height. So the ball reaches to this certain height, let's say, and suppose it takes a duration of 3 seconds for it to travel a height h. Okay. So suppose initially it was thrown with a certain velocity u. What will be the final velocity at the highest point?
0, sir.
0, right? So at the highest point, its velocity will be equal to 0.
Mm. Yes, sir.
So I'll be getting this value. From this, if I want to find out the average velocity, so my average velocity will be equal to total displacement, that is height, divided by
Sure, sir.
total time, which is 3
Mm.
seconds. Got it?
Yes, sir.
When I talk of instantaneous velocity, so initially I threw it with a certain velocity u. Okay,
Yes.
this u can be any value like 10 meter per second or 20 meter per second. So suppose I threw this with a speed of 30 meter per second, right?
Yes, sir.
So suppose I threw it with a speed of 30 meter per second. So at this point, my speed was 30 meter per second. And as the ball goes up, its velocity decreases at every point of time.
Yes, sir.
Okay. So can I say this value or initial velocity to be 30 meter per second? Can I call to it to be the velocity at the instant when the ball was thrown, right?
Yes, sir.
Velocity at instant when ball was thrown, and v is the velocity at the instant when the ball is at the highest point,
Okay,
right?
sir.
So this is velocity at instant when ball is at highest point.
Sir, in
Uh,
our, sir,
yes.
sir, in our college, they started loss of motion, sir, today.
Okay. So see, there
Yes.
is one thing. If we try to skip it and run through it, so you will not be able to get even this one, and
Oh,
you
yes,
will
sir.
not be able to get even the motion in the plane.
Yes, sir.
Okay. So I'm trying to get it as quickly as possible through it.
Okay, sir.
Okay. So I'm,
Yes, sir.
I'm trying to do as quickly.
Okay, sir.
So here, this value is the instantaneous velocity, 30 meter per second.
Yes, sir. Yes, sir.
Okay. And this velocity is also the instantaneous velocity.
Yes, sir.
Okay. As I'm talking of velocity at the instant when ball is at the highest point. So this is the instantaneous velocity. But what I am obtaining over here, average velocity will be h by 3. This is my average velocity. Got it?
Yes, I got it.
Okay. So whenever we need to find out the instantaneous velocity, we will be using the calculus method of obtaining v equals to, we can define v as dx by dt, that is change of position with respect to time. This will
Yes.
be the instantaneous velocity. Also, if I find out the instantaneous acceleration, so instantaneous acceleration will be given by the formula dv by dt. That is
Sir,
instantaneous value of the change of velocity with time.
sir,
Yes.
sir, I don't know how to use this integration and differentiation in problems, sir.
Okay, so has it been given anywhere in your college?
Yes, sir. There are m- uh, mains books, sir. So in that we have to use right, sir.
Mhm.
So that I'm not getting, sir. How to
Okay,
use it?
see.
Yes, sir.
Okay,
In
okay, see.
proper.
For the differentiation, you need to remember certain formulas. Like
Yeah.
the differentiation of this one, the differentiation which we call d by dx of x to the power n will be given as n x to the power n minus 1.
Okay.
Okay.
Yes.
Then differentiation of that is d by dx of a constant value k. So if you have any constant value k, its differentiation will be equal to 0.
Okay.
Okay. Then if you have like d by dx of a multiply x to the power n, so since a constant is multiplied with a variable, so constant will be taken out of the differentiation like this. You will be writing it a, then apply the rule of differentiation. So I will write a, then dx to the power n over n, d by dx of x to the power n over dx. So this can be again evaluated as a multiply x to the power n minus 1. So a n multiplied with x to the power n minus 1. Got it?
Yes, sir.
Okay. This there are various other formulas like for the trigonometry also, for algebra also there are different formulas. So I'll be giving you just few of them. Like for trigonometry, you have d by dx of sine x is equal to cos x. You have d by dx or differentiation of cos x is equal to sine x.
Yes,
Then
sir. Got.
whenever you have a differentiation of log x, so d by dx or differentiation of log x is 1 by x. Right? D by dx of log x. So it's equal to 1 by x.
Sir, these mean
Yeah,
problems, sir.
yeah, just once you are aware of the formula, then you can start with the
Okay.
problems.
Yes, sir.
Okay.
Yeah.
So like this question, see, the position of a particle as a function of time is given as h, and you need to find the position of the particle at t equals to 0. You need to find position of the particle at t equals to 4 seconds and 2 seconds. Then you need to find the displacement of the particle. Sorry, let's make it the displacement. I want displacement okay. Then finally, I want the velocity, or let's say I want the average velocity during 0 to 4 seconds. Also, I want, yes,
Sir, yes, sir.
yes.
What you're writing, sir?
It's the question, just the question you need to solve.
Okay. Okay, sir.
Okay, actually, if I go on searching for the question, it will take some time. If you had informed me earlier, I have already have a number of questions from this topic. So I want velocity at t equals to 3 seconds. So let's try to solve this up. You are given the position of a particle as a function of time, which is given as x equals to 4t squared minus 5t minus 1. So this is an expression which is given for position as a function of time. Then you need to find out the position of the particle at t equals to 0. So how can you evaluate the position at t equals to 0?
So the time is 0, sir.
Okay, so just write 0, and what do we get this position as? Minus 1?
Yes, sir, -1. Sir, in place of a
For,
t, we have to substitute 0, sir.
yeah. So just at the place of t, you need to substitute 0, you'll get the position as minus 1. Can you tell the displacement
Yes,
of
sir.
the particle between t equals to 4 second and 2 second?
2 seconds. Sir, -2, sir.
Okay, what is the position at t equals to 2 second? If I put t equals to 2, so I'm
Yes, sir.
getting x as 4 multiplied 2 squared, that is 4 minus 5 multiplied 2 minus 1. So 16 minus 11, that is 4. So position at t equals to 2 is 5, and you need to find position at t equals to 4 seconds. So we'll put t as 4 over here. You get 4 multiply 4 squared minus 5 multiply 4 minus 1. So we get this as
Mhm.
64 minus 21.
Yes,
So
sir.
this I get as 43, right?
Yes, sir.
So here your position at t equals to 4 is 43. The position at t equals to 2 is 5. Now what will be the displacement?
So displacement.
I want the displacement during this time.
Sir, 38, sir.
38, right? So here
Yes, sir.
answer to the second one I got the displacement as 38. Now you got it?
Yes, sir.
The third one says the average velocity during 0 to 4 seconds. So what will be the average velocity between
So,
0 to 4 seconds?
total displacement by total time taken.
Yeah, so what will be the total displacement here?
The total displacement is
Between 0 to 4 seconds.
yes, sir.
So what will be the total displacement?
So 50, sir.
50. No, not 50.
Uh,
Okay, what is the position at t equals to 0?
-1, sir.
Minus 1, and the position at t equals to 4 is 43, right?
Yes, sir.
So the displacement will be given as final position minus initial position.
Mm.
So your
Yes, sir.
final position is 43. You get final position 43 minus the initial position, which is minus 1.
Yes, sir.
You get 43 plus
40,
1, that is 44
44.
meters.
Yes, sir.
So the average velocity will be total displacement, which is 44 divided by total time, which is 4. So is it 11 meter per second? Got it?
Yes, sir. 11 meter per second.
Okay. Now, okay, do you want to note it down?
Yes, sir. I'm writing,
Okay.
sir.
Okay, so write it and when completed, just move on. So we'll start the fourth question.
Okay, sir.
बच्चे पाठक
Done, sir.
Okay.
Yes,
So
sir.
what is it? Okay. Now how will we find out? See, now we have to find the velocity at a given instant.
Yes,
That
sir.
is
So,
velocity at t equals to 3 seconds.
yes, sir.
So which type of velocity is it? Is it average or instantaneous?
Instantaneous, sir.
Instantaneous.
Yes, sir.
Just hold for 1 minute.
What, sir?
Okay. So we need to find here the velocity at t equals to 3 seconds. So can I say that this is the instantaneous velocity which is required?
Yes, sir.
Okay. So for this, I think I need to find a differentiated, and after differentiation, I will be able to get the equation of velocity,
Okay, sir.
right?
Yes, sir.
So I have the expression x equals 4t squared minus 5t plus 1. Okay.
Yes.
So if I differentiate it, so see, I'm writing d by dt on both the sides. So on the left hand side, I will get dx by dt, and on the right hand side, I will get here d by dt of,
Sir,
yes,
sir, it's 40 square minus 5t minus 1, sir. Not
okay,
plus
it's
1.
minus 1.
Yes.
Okay, it won't affect the expression, but still I'm changing it.
Okay.
So this is minus 1, got it.
Yes, sir.
Minus 1, so you have 5t squared minus 1, got it?
Yes, sir.
Okay, so this dx by dt is velocity, and we have velocity is equals to uh, d by dt of this. So on this side, differentiation distributes over addition and subtraction. So I'll be writing it as 4 times of d by dt of, okay, let me write it completely then. Otherwise you won't understand. So I'm getting d by dt of 4t squared minus d by dt of 5t squared minus d by dt of 1. Got it? I've just distributed
Sir, question.
differentiation. Yeah, what happened?
Yes, sir.
Now, here,
Sir, this
as per
question,
our rule, Mhm.
no doubt, sir. Sir,
Yeah, what is,
in this question, why we have to use,
why we?
sir, why we have to use this, sir, here?
Yeah, see, because the instantaneous velocity will be given by dx by dt. If you have a differentiation of x over time, so dx by dt gives me the instantaneous velocity.
Okay, sir.
Okay,
Yes, sir.
so
Yes, sir.
that is
Got.
why. So that is why I need to differentiate it, and hence I have applied d by dt on both the sides. So on
Okay,
the
sir.
left hand side, I got dx by dt, which is equal to v, and on the right hand side, I have d by dt of 4t squared minus d by dt of 5t squared minus d by dt of 1.
Yes,
Got
sir.
it?
Yes, sir.
So now, as per our rule, I will be taking this 4 outside, and I have inside d by dt of t squared. Here I have minus 5 outside, then d by dt of t. Here it's t, not t squared. Yes. It's okay. Is it okay now? Let's check
Yes,
it.
sir.
Minus 5t, and here minus d by dt of 1. So I know, as per the formulas that I gave you, the differentiation of a constant is 0.
Yes, sir. Zero.
Okay. So this will be, I will evaluate this to be 0. And here dt by dt cancels. So I have 1. So here I get just minus 5. Got it?
Yes, sir.
For this one, I'll be using the formula d by dx x to the power n.
Okay, sir.
Okay. So the formula is here. It's the formula says we have to use d by dx of x to the power n. So this is equal to n x to the power n minus 1.
Yes, sir.
Okay. So n x to the power n minus 1. So hence I can write it now. Here it is t to the power 2. So I'll be writing 4 multiply 2 multiply t to the power 2 minus 1. Is this correct?
Yes, sir. Got it.
Got it? And
Yes,
here
sir.
you have minus 5 plus 0. So plus 0 can be left out. Now here I just have 8t minus 5. Got it?
Yes, sir.
So finally, I got the formula for velocity. So this is the formula for velocity that I've got. I've got v equals to 8t minus 5.
Yes, sir.
So its velocity is equal to 8t minus 5. And hence, I can evaluate or I can find the velocity at t equals to 4 second now. Or it says 3 second. I think the question says 3 second. So I'll
Four,
use
sir.
t equals to 4.
Uh, no, sir.
Yeah, it's 3 second.
Yes, sir.
I
Three
have to
only, sir.
find velocity at t equals to 3 second.
Yes,
So
sir.
I'll be using this. I'll put here 8 multiply 3 minus 5. So it's 24 minus 5,
Yes,
and
sir.
24 minus 5 will be equal to
19.
19.
Yes, sir.
So the velocity at this instant is 19 meter per second.
Okay, sir.
Got it now?
Yes, sir. Got it.
Okay. So I hope you will you try one question on yourself.
Yes, sir.
Okay. So let's see if you have here any question from your side. See, this is what has been written here also. Instantaneous velocity, instantaneous acceleration. See, instantaneous velocity is given by dx by dt. Instantaneous acceleration is dv by dt.
Yes, sir.
So, okay, are there no questions over here?
What, sir?
Just
Yes, sir.
Anjani, Anjani Graham. Mm, mm. I'm searching for some question which has some values for instantaneous velocities.
Okay, sir.
Okay, in the next class, we'll be solving these questions which are given here in your book. Okay?
Sir.
I think it's the same book that I had.
What book you have, sir?
It's okay, just 1 minute. Yeah, see this question. I'm searching for this question like this. So I think you can try out. It's from your book only. So this
Okay, sir.
question 3.22. You can try out this question. Okay. The motion of a particle along a straight line is described by the function s equals to 6 plus 4t squared minus t to the power 4.
Yes, sir. Sir, it's blur, sir.
S is equal to 6 plus 4t squared minus t to the power 4. Okay, you have to find velocity and acceleration at t equals to 2 seconds. Also find the
Okay, sir.
average velocity during the third second. So we'll come to the average velocity later. First, to find out the velocity at t equals to 2 seconds.
Okay, sir.
Okay, so are you able to get it?
Yes, sir, I'm
Vishal?
doing. Yes, sir, I'm doing.
Okay.
Yes. Yes, sir. I got velocity, sir.
Okay.
So,
What is the velocity you are getting? Okay, I
sir,
just check your expression. You should have got the expression like this. 8t minus 4t cube. Is this what you got?
yes, sir.
Okay. So now you can evaluate the velocity at t equals to 2 seconds. So this will be getting
Yes.
v at t equals to 2 as 8 multiply 2 minus 4 multiply 8. So this is 16 minus 32, which is negative 32 meter per second. Is this?
Minus
Yeah,
16,
Ishan.
sir.
What?
Min
Oh, sorry, negative 16, not 32. Negative 16.
yes,
So
yes,
did you
sir.
get this? Negative 16
Yes,
meter per
sir.
second.
Yes, sir.
Okay. Now,
Minus 16
now
per second.
find the expression for acceleration.
Okay, sir. Sir, here what formula you have to use, sir, for acceleration?
What?
Sir, here what formula you have to use, sir?
Now see, I have got the formula for velocity
Yes.
and I want acceleration now. So acceleration is equal to dv by dt.
Yes, sir.
So now I will differentiate this formula to obtain the formula for acceleration.
Okay, sir.
Good. Hmm? Okay, so did you get the formula for acceleration?
Oh, yes, sir.
Okay, so I think you would have got, just check, you would have got acceleration equals to 8 minus 12 t squared.
Yes, sir.
Did you get this one?
Yes, sir.
So to evaluate acceleration at t equals to 2 seconds, you put here t equals to 2, so you get a equals to 8 minus 12 multiplied 2 squared, so 2 squared is 4.
Oh, yes,
So
sir.
it will be 8 minus 48, and 8 minus 48 is
Mhm.
negative 40 meter per second square.
Yes, sir. Negative 40 meter per second.
Got it? 40 meter
Yes,
per second square.
yes, sir.
So I think now you can solve such questions using
Yes, sir.
differentiation and integration.
Yes, sir. Got it, sir.
Okay. So try to find such questions more in your book. There may be some more questions. I
Okay.
think,
Sir, and integration is also there, sir.
yeah, integration is also there, but just go step by step. Okay.
Okay. Yes, sir.
First, you started with differentiation. Let's do some questions of differentiation. Then we move on to integration. Okay.
Okay, sir. Yes, sir.
So, okay, we'll do try to do one question from average velocity.
Sir, you're teaching from
Yeah.
Hyderabad only, sir.
What happened?
Sir, you're teaching from Hyderabad only.
Teaching from
Hyderabad, sir.
the. I'm not getting.
Sir, no, sir. I'm saying that you're teaching from where, sir?
I'm teaching from Gorakhpur.
Okay, sir.
Okay, so earlier I was located in Jaipur, but after COVID I shifted to this place.
Okay, sir.
So in case, if is there any problem, anything that you want to know?
No, sir. I'm just asking, sir.
Okay,
Yes, sir.
so okay, if suits, maybe I may be available at Hyderabad or maybe some later time. Currently, I don't wish to go anywhere. Currently, I'm good here at Gorakhpur, my place. Okay,
Okay, sir. Yes, sir.
so all the classes I'm taking online only right now. So that's why I'm not thinking of shifting
Okay,
anywhere.
okay, sir.
So a body starts from rest and moves with a uniform acceleration of 5 meter per second square for 8 seconds. From that time, the acceleration ceases. Find the distance covered in 12 seconds, starting from rest. So, what all information is given in this question?
Sir, velocity is given, sir, after
Which
time.
velocity? Which velocity is given?
Uh, Initial
Okay,
velocities.
initial velocities. What is the initial velocity here?
Sir, sir, time is given, sir. 8 seconds.
See, initial velocity is zero. Okay, we'll
Yes, sir.
discuss this question in our next class. Okay,
Okay, sir.
okay, bye.
Thank you, sir.
Okay, are you taking other chemistry classes also?
No, sir. Only physics, sir.
Okay, so and you have booked for 3 classes in a week, right?
Oh, yes, sir.
Okay. Okay, fine. So, however, I take some personal coachings also on the same basis. Maybe. Okay, bye.
Thank you, sir. Bye, sir.